In this video we will draw the profile of the cam. So in the last video we saw how to draw the displacement diagram. So we have the displacement diagram here. This is the ascent 5D 5A for 150 degrees. Then you have a dwell for 60 degrees. Then a descent for 100 degrees, and the remaining 50 degrees we have another dwell. So the scale which we took while which we used while drawing this displacement diagram was h is equal to 30 mm. We took it as 6 centimeters, that is 5 mm is equal to 1 centimeter. So using the same scale, so while drawing the profile also you have to use the same scale which you used while drawing the displacement diagram. Now RC is given as 20 mm. So using this scale we see that RC is equal to 4 centimeters. So now you draw a circle here with radius 4 centimeters. Okay, so the radius of this circle is 4 centimeters. Next, after that, and the top of this circle you draw a knife edge follower. So in the problem we had the follower as a knife edge follower. So just mark a point. We will call this as 0 dash. At that point you draw vertically above the circle, you draw a knife edge like this. Okay, afterwards now we have to divide this circle into the angle of ascent, next dwell, first dwell, then angle of descent and second dwell. Okay, now starting from this point we have to mark 150 degrees. From this point we have to mark 150 degrees in the counterclockwise direction. Now while developing the profile, suppose the cam is let us say the cam is moving rotating in a clockwise direction, and naturally the follower will stay in this position and it will move up and down. Now instead of that, what we will do is we will keep the cam stationary, because the cam was rotating in clockwise direction. It is same when you have the cam as stationary and make this knife edge follower rotate in counterclockwise direction, the effect will be same. So we will draw the profile in the counterclockwise direction. So now angle of ascent must be marked in counterclockwise direction first. So what was the angle? The angle of ascent was 150 degrees. So from this line you mark 150 degrees in the counterclockwise direction. So that we will do here. Approximately I will mark here. So we will see what will be the angle. So this is, let us say, you draw one line like this at 150 degrees. Then from here you mark the next dwell angle, that is 60 degrees. And we have a 60 degrees dwell. Then we have a 100-degree descent. So that is the 100-degree descent. Now, so this is the first angle that is marked. This is 150 degrees. This is the angle of ascent. Then we have the dwell 60 degrees. Then we have the descent 100 degrees, and then we have another dwell. This is 50 degrees. Now we have divided the angle of ascent here into 6 parts. So the angle of ascent is 150 degrees. So this arc also must be divided into 6 equal parts. So it must be divided into 6 equal parts. So first part is here like this. This is second part. Third part. That is the fifth part. That is the sixth part. Now we have divided this 150-degree angle of ascent into 6 parts. 1, 2, 3, 4, 5 and 6 equal parts. You have this must be divided into 6 equal parts, because during the ascent we have divided the displacement diagram on the x-axis into 6 equal parts. Here also we divide it into 6 equal parts. Now you mark the numbers now. So in the displacement diagram we had 1, 2, 3, 4, 5, 6 at the bottom. So in the cam profile diagram you mark those numbers here as 1, 2, 3, 4, 5 and 6 and on the circle, on the base circle. Now take a compass and take this length 1 dash, okay, and mark it on the first line. Say you take the compass and mark it, you mark it here. So say this is 1 dash. Then you take the length 2 dash and mark it on the line second segment from 2 to 2 dash. This is 2 dash, 2 to 2 dash. Then similarly from 3 to 3 dash. So starting from 3 here, 3 dash. Similarly take the length 4 dash and from 4 you mark it here 4 dash. Let us say this is 4 dash. Similarly 5 dash, from 5 to 5 dash. Then from 6 to 6 dash. Okay, so here this 1 dash must be equal to this 1 dash, and this 2 dash, the length 2 dash must be equal to this length 2 dash. Similarly the length 3 dash must be equal to this 3 dash, and this length 4 dash must be equal to this length 4 dash, and this length 5 dash must be equal to 5 dash, and this length 6 dash must be equal to 6 dash. Now this point is also now 6 here. This point, you see, this point is also 6, because from here to here it is a dwell. Okay, so dwell, so here you see in the displacement diagram we have 6 here, and also we have 6 again, we start with 6 here. So because we are ending here, we are starting from 0, 1, 2, 3, 4, 5, 6. Then again after the dwell you again start with 6 here, as we have done in the displacement diagram. So this is 6. Now again mark 6 dash. So this 6 dash and this 6 dash are same. Therefore this 6 dash and here 6 dash must be same. Okay, so let us say this is 6 dash. Now what you should do is you have to divide the angle of descent. This is angle of descent 100 degrees. So in the displacement diagram we have divided the angle of descent also into 6 equal parts. So now again we have to divide this 100 degrees into 6 equal parts. So how will we do that again? As we did before, we'll just divide it into 6 equal parts. Okay. First part, second part, third part, fourth. So join these points, one there. Join the remaining points now from 7 there, from 8 there. And 11 dash, and then 12 dash. Okay, so this red line is the cam profile. So this is the shape of the cam for the given displacement of the follower. So the ascent is with simple harmonic motion and the descent is with constant velocity. So that is how you draw this cam profile. You practice this using on a drawing sheet using a mini drafter. So without the drafter you can't do it. So you do it properly using a mini drafter and drawing sheet. So here what we have done is, first we have drawn the circle, and then you mark the angle of ascent, that is 150 degrees, then the first dwell 60 degrees, then the angle of descent 100 degrees, and the second dwell 50 degrees. Now the angle of ascent is divided into 6 equal parts because we have divided the displacement diagram also on the x-axis into 6 equal parts. So you mark the numbers 1, 2, 3, 4, 5, 6. So divide it into 6 equal parts, and on these radial lines transfer the lengths 1, 1 dash here, then 2, 2 dash on the second line, 3, 3 dash here. So we are transferring all these lengths on these lines here, 5, 5 dash and 6, 6 dash. And then we have a dwell period of 60 degrees. So here we need not do anything, just we can mark an arc, taking this as a center, just draw an arc from 6 to 6 dash. So this will be the profile for the 60 degrees dwell. Then we have 6 again, we have the angle of descent and it is 100 degrees. Okay, that also we have to divide into 6 equal parts here. So because we have divided it into 6 equal parts in the velocity, constant velocity descent follower motion, okay, in the displacement diagram. So, and we have marked the numbers 6, 7, 8, 9, 10, 11, 12. Here also we start with again 6, 7, 8, 9, 10, 11 and 12. Then transfer these heights. Now 6, 6 dash is here, then 7, 7 dash is here, again we have 8, 8 dash, then we have 9, 9 dash here, and this 10, 10 dash is transferred here, again 10, 10 dash, then 11, 11 dash is marked here, then we have 12 and 12 dash is the same point. So now all these points, that is 1 dash, 2 dash, 3 dash up to 11 dash and 12 dash must be joined by a smooth curve. You have to use free hand and draw this smooth curve which is shown in the red line here in the video. So this red line will be the profile of the cam. So this again you practice in your drawing sheet using a mini drafter. Mark these points and then smoothly join all these points with a smooth curve, and that will give you the profile of the cam for the required motion of the follower. Okay, so this is the procedure of drawing the cam profile. Now we have omega is equal to 2 pi n by 60. that is equal to 2 pi into 120 by 60, that is equal to 12.57 radians per second. And now we also know that Vmax for simple harmonic motion is h by 2 into pi omega by 5a, or that is equal to 30 by 2 into pi into 12.57 by 150, that is in degrees, convert it into radians, multiply by pi and divide by 180, and that then it will come to 26.3 mm per second. So that is the maximum velocity of the follower. Okay. Then also we will find the maximum acceleration. F max is equal to h by 2 into pi omega by 5a whole square. So that is equal to 30 by 2 into pi into 12.57 divided by 150 into pi by 180 whole square. So that is equal to 3413 mm per second square. So this is the velocity, maximum velocity and maximum acceleration during ascent with simple harmonic motion. So these formulas are for simple harmonic motion. Okay, Vmax for simple harmonic motion and Fmax is for simple harmonic motion. Now during descent also we will calculate the maximum velocity and the maximum acceleration. So Vmax is equal to h into omega by 5d, that is equal to 30 into 12.57 divided by 5d is 100 into, convert it into radians, 5 multiply by 5 and divide by 180, that is 216 mm per second. So that is the maximum velocity during descent. Of course we are using constant velocity descent. Fmax is equal to 0 because velocity is constant during descent. So this is Vmax and Fmax during descent with constant velocity of follower. Okay. So those are the things he has asked in the problem. So that is the end of this problem. The next video we will try to draw another cam profile.